Hello, in this lecture we'll answer two questions. In the first question, we'll find out the value of line segment X that is inside rectangle ABCD. And in the second question, we'll find out the value of the green area, the value of the green shape that is inside a semicircle. Okay, so we'll start with the first question. In the drawing, we have rectangle ABCD. Inside rectangle ABCD, we have this circle. We know that the tangent from point A to this circle is equal to 33 units. The tangent from point B to this circle is equal to 85 units. And the tangent from point C to this circle, the length of the tangent is unknown. It is equal to x. That is the line segment that we are looking for. And finally, the tangent from point D to this circle is equal to 35 units in its length. And our mission is our dimension to find out the length of the tangent from point C to this circle, that is equal to x. So we have to find out the value of x. Okay. So first of all, we will define the center of this circle as O. We will define the point of tendency of the tangent from point A to this circle as point E. We define the point of tendency of the tangent from point B to this circle as point F. We will define the point of tendency of the tangent from point C to this circle as H. That's actually the tangent that we are looking for. We want to find out the length of tangent CH, that is equal to x. And finally, we'll define the tangent from point D to this circle as point T. We join points O and E together by a straight line. So point O is the center of the circle, point E is the point of the circle itself, therefore OE is the radius of this circle that we define as R. And we have here rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. We have here tangent AB that is tangent to this circle at point M. Point M is the point of tendency. And we have the radius OM that is drawn to the point of tendency. Therefore, according to this rule number 1, tangent AB will be perpendicular to the radius MO. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. We can implement problem number 1 in our drawing. For the number drawing, we have the radius OE that is drawn to the point of tendency. Therefore, according to rule number 1, this angle will be equal to 90 degrees. Likewise, we join points O and F together by a straight line. Point O is the center of the circle, point F is the point of the circle itself, therefore OF is the radius of this circle that is equal to R. We have the radius OF that is drawn to the point of tendency, therefore according to rule number 1, this angle will be equal to 90 degrees. Likewise, we join points O and H together by a straight line. Again, point O is the center of the circle, point H is the point of the circle itself, therefore OH is the radius of the circle that is equal to R, and we have the radius OH that is drawn to the point of tendency, therefore according to rule number 1, this angle will be equal to 90 degrees. And finally, we join points O and T together by a straight line. Again, point O is the center of the circle, point T is the point of the circle itself, therefore OT is the radius of the circle that is equal to R. And we have the radius OT that is drawn to the point of tendency, therefore, according to rule number 1, this angle will be equal to 90 degrees. In the next step, we'll join points A and O together by a straight line. And we will implement the Pythagoras theorem on the green right triangle, the triangle AOE. On the green right triangle, triangle AOE, by PT is the relation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle, triangle AOE is AO. Therefore, the square of the hypotenuse is AO square. And it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to OE square plus AE square. So I found out that according to the Pythagoras theorem, on the right green triangle, triangle AOE, AO square equals to OE square plus AE square. Okay, so AO is AO square equals to OE square. OE equals to R, therefore OE square is R square plus AE square. AE equals to 33 units according to what is given as a equation, therefore AE square is 33 square. So in conclusion, we found out that according to equation number 1, AO square equals to R square plus 33 square. In the next step, we'll join points B and O together by a straight line. And we'll implement the Pythagoras theorem on the yellow green triangle BOF. According to the Pythagoras theorem, in the yellow right triangle BOF by PT, we'll get that BO square equals to OF square plus FB square. I repeat again, in the yellow right triangle BOF, according to the Pythagoras theorem, we get that BO square equals to OF square plus FB square. So here BO square equals to OF square. OF is R, therefore OF square is R square plus FB square. FB equals to 85 units according to what is given as the question. Therefore FB square is 85 square. So in conclusion, we found out that according to equation number 2, BO square equals to R square plus 85 square. In the next step, we will join points C and O together by a straight line. And we will implement the Pythagoras theorem on the right orange triangle edge OC. According to the Pythagoras theorem, the right orange triangle edge OC CO square, that is the square of the hypotenuse, equals to OH square plus HC square. Repeat again. In the right orange triangle edge OC, according to the Pythagoras theorem, we get that CO square equals to OH square plus HC square. So CO square equals to h O square. H O equals to R, therefore h O square will be equal to R square plus hc square. hc equals to x, therefore hc square will be equal to x square. So according to equation number 3, we found out that CO square equals to R square plus X square. And finally, we join points D and O together by a straight line. And we'll implement the Pythagoras theorem on the pin right triangle, triangle DTO. In the pin right triangle, triangle DTO by PT, DO square equals to TO square plus TD square. Repeat again. In the pin right triangle, triangle DTO, DO square equals to TO square plus TD square. That is to say, according to equation number 4, DO square equals to TO square. TO equals to R, therefore TO square is R square plus TD square. According to what is given as the equation, TD equals to 35 units, therefore TD square is 35 square. So in conclusion, according to equation number 4, we found out that DO square equals to R square plus 35 square. In the next step, I will copy the 4 equations that we created here in a new page. So actually, according to equation number 1, we found out that AO square equals to R square plus 33 square. According to equation number 2, we found out that BO square equals to OF square. BO square equals to R square plus 85 square. According to equation number 3, we found out that CO square equals to R square plus X square. And finally, according to equation number 4, we found out that DO square equals to R square plus 35 square. Okay. the next step, I'll copy rectangle ABCD with its circle that is inside the rectangle in a new page, and we will analyze the rectangle with its circle inside it. So we have rectangle ABCD. So this is actually rectangle ABCD that I copied from the original drawing with its circle inside it. We know that all the angles inside the rectangle are right angles, so this angle equals to 90 degrees. This angle will be also equal to 90 degrees. This angle equals to 90 degrees, and finally this angle, it is also equal to 90 degrees. In the next step, we will do two constructions from the center of the circle, that is, say, from point O. We will draw perpendicular on AB. So actually this angle equals to 90 degrees, and this angle, it is also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AB as T. But because of the fact that in rectangle ABCD, side AB is parallel to side DC, it means that if from point O we do perpendicular on AB, it means that that perpendicular must be also perpendicular to DC. Why? Because AB is parallel to DC, therefore the perpendicular on AB must be also perpendicular on DC. So that is to say, this angle must be also equal to 90 degrees, and this angle must be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and DC as M. In the next step, from point O, we go perpendicular on BC. So actually, this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and BC as point S. But again, because of the fact that in rectangle ABCD, side BC is parallel to side AD, it means that the perpendicular from point O and on BC must also perpendicular to AD, because AD is parallel to BC. Okay, so here this angle must be also equal to 90 degrees, and this angle must be also equal to 90 degrees according to our construction, and according to the rule that when you draw perpendicular to two parallel lines, when you draw perpendicular to a parallel line, to a straight line, and you have another straight line that is parallel to that straight line, then the perpendicular must also be perpendicular to the other straight line. So we define the touching point of the perpendicular from point O and AD as H. Okay, so here inside quadrilateral ATHO we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. Therefore, the fourth angle must be also equal to 90 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. 270 degrees plus 90 degrees is 360 degrees. That is the sum of the angles in any quadrilateral. Exactly for the same reason, if you focus on quadrilateral and or DM, in this quadrilateral we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees. Likewise in quadrilateral TBOS, we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees. And finally, inside quadrilateral OSMC, we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees. So here, we created here 4 quadrilaterals with 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, so we relate to those 4 quadrilaterals, those 4 small quadrilaterals, 1, 2, 3, 4, as rectangles. And we know that the opposite sides of a rectangle are equal to each other. We define side AH as edge 1, we define side HD as edge 2, we will define side AT as B1, and we will define side TB as B2. I repeat again, we have the rule that the opposite sides of a rectangle are equal to each other, so we will focus on rectangle ATHO. In this rectangle, the opposite sides must be equal to each other. That is to say, side AH equals to side TO. But we know that AH equals to edge 1, therefore TO must be also equal to edge 1. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, in rectangle ATHO, AT must be equal to edge O. But we know that AT equals to B1, therefore edge O must be also equal to B1. Likewise, in rectangle edge ODM, side edge O must be equal to side DM. But edge O equals to B1, therefore DM must be also equal to B1. According to the same rule, edge D must be equal to OM. But edge D equals to H2, therefore OM must be also equal to H2. Likewise, in rectangle TBOS, TO equals to BS, but we know that TO equals to H1, therefore BS must be also equal to H1. In the same rectangle TBOS, TB must be equal to OS, but we know that TB equals to B2, therefore OS must be also equal to B2. And finally, in rectangle OSMC, OM must be equal to SC. But we know that OM equals to H2, therefore SC must be also equal to H2. And finally, OS must be equal to MC according to the same rule. But we know that OS equals to B2, therefore MC must be also equal to B2. So in the next step, we'll join points A and O together by a straight line. And we'll focus on the green right triangle, triangle ATO. In the green right triangle, triangle ATO, according to the Pythagoras theorem, AO square equals to B1 square plus H1 square. Again, AO square equals to B1 square plus H1 square. We'll join points B and O together by a straight line. Here, in the yellow right triangle, triangle OBT. Again, in the yellow triangle, in the yellow right triangle, triangle OBT, according to the Pythagoras theorem, BO square equals to B2 square plus H1 square. Repeat again, in the yellow right triangle, BO square equals to B2 square plus H1 square. We'll join points O and C together by a straight line. Here in the orange right triangle, triangle OSC, this orange right triangle, according to the Pythagoras theorem, we get that CO square equals to B2 square plus H2 square. Okay, repeat again, in the orange triangle, triangle OSC, according to the Pythagoras theorem, CO square equals to B2 square plus H2 square. And finally, we join points O and D together by a straight line. and we'll focus on the pink right triangle HDO. On the pink right triangle HDO. According to the Pythagoras theorem, we get that DO square equals to B1 square plus H2 square. I repeat again, in the orange triangle, according to the Pythagoras theorem, DO square equals to B1 square plus H2 square. Okay, so here we created another 4 equations for AO square, BO square, CO square, and DO square. In the next step, we will create another 4 equations equation number 1 states that AO square, according to this equation number 1, must be equal to AO square according to this equation number 2. AO square according to this equation number 1 is R square plus 33 square, and it must be equal to AO square according to this equation number 2, that is B1 square plus H1 square. Likewise, we create equation number 2 that states that BO square according to this equation number 1 must be equal to BO square according to this equation number 2. So BO square according to equation number 1 is equal to R square plus 85 square, and it must be equal to BO square according to this equation number 2, that is equal to B2 square plus H1 square. Likewise, we create the third equation that states that CO square according to this equation number 1 must be equal to CO square according to this equation number 2. So CO square according to equation number 1 is equal to R square plus X square, and it must be equal to CO square according to this equation number 2, that is equal to B2 square plus H2 square. And finally, we create equation number 4 that states that DO square according to this equation number 1 must be equal to DO square according to this equation number 2. So DO square according to this equation number 1 is equal to R square plus 35 square, and it must be equal to DO square according to this equation number 2, that is B1 square plus H2 square. So here we have 4 new equations, and in the next step we subtract equation number 1 from equation number 2. That is to say, equation number 2 minus equation number 1. So here equation number 2 is, in this side of equation number 2 we have R square plus 85 square minus equation number 1. In this side we have R square plus 33 square, and it must be equal to this side of equation number 2, that is b2 square plus h1 square minus equation number 1 that is b1 square plus h1 square. So this will be equation number 5. Now we'll open the brackets of this equation number 5, and you'll get that according to equation number 5, so we'll open the brackets here, r square plus 85 square r square plus 85 square. We have minus before the bracket, so it will be minus r square minus 33 square equals to b2 square plus h1 square. We have minus before the bracket, so it will be minus b1 square minus h1 square. Okay, so here in this side of equation number 5 we have r square minus r square is 0, so r square will get cancelled. On the other side of equation number 5 we have h1 square minus h1 square, that is 0, so h1 square will also get cancelled. So what is left from equation number 5 after we cancel those two expressions? In this side of the equation we left only with 85 square minus 33 square, that is equal to b2 square minus b1 square. Okay. In the next step, we will subtract equation number 3 from equation number 1. So it is 4 minus 3. So in equation number 3 we have here, this will be equation number 6. In equation number 4 we have here r square plus 35 square minus equation number 3 we have here minus r square plus x square, that is equal to, in equation number 4 we have, this is equation number 4 minus equation number 3, so in equation number 4 we have here b1 square plus h2 square minus equation number 3 we have here minus b2 square plus h2 square. In the next step we will open the brackets on this equation number 6, and we get that according to equation number 6, r square plus 35 square. We have minus before the bracket, so here we will have minus r square minus x square, that is equal to b1 square plus h2 square. We have minus before the bracket, so it will become minus b2 square minus h2 square. So here in this side of equation number 6 we have r square minus r square is 0, so r square will get cancelled. In the other side of the equation number 6, we have h2 square minus h2 square is 0, so h2 will also get cancelled. So what is left from equation number 6 after we cancelled those two expressions? What is left is that in this side of equation number 6 we left only with 35 square minus x square, that is equal to b1 square minus b2 square. Here we'll multiply this equation number 6 by minus 1, and we get that according to equation number 1, according to equation number 6, we have in this side of equation number 6 35 square, minus 1 is minus 35 square, and we have here minus x square times minus 1 is plus x square. So in this side of equation number 6 we have x square minus 35x minus 35 square, that is equal to, so we multiplied both sides by minus 1. Minus b2 square times minus 1 is b2 square, and b1 square times minus 1 is minus b1 square. So according to equation number 6, we found out that b2 square minus b1 square equals to x square minus 35 square. While according to equation number 5, we found out that b2 square minus b1 square equals to 85 square minus 33 square. In the next step, we'll create equation number 7. Equation number 7 states that b2 square minus b1 square according to equation number 5 must be equal to b2 square minus b1 square according to equation number 6. So b2 square minus b1 square according to this equation number 5 equals to 85 square minus 33 square. And it must be equal to b2 square minus b1 square according to this equation number 6. And b2 square minus b1 square according to equation number 6 equals to x square minus 35 square. So according to equation number 7, we found out that 85 square minus 33 square equals to x square minus 35 square. Here we add 35 square to this equation number 7, and we'll get that according to this equation number 7, 85 square plus 35 square minus 33 square equals to x square. X is the variable that we are looking for, the line segment that we are looking for. 85 square equals to 7,225 plus 35 square. 35 square equals to 1,225 minus 33 square is 1,089. That is equal to x square. So here 7,225 plus 1,225 is equal to 8,450 minus 1,089 equals to x squared. So actually 8,450 minus 1,089 equals to 7,361, that is equal to x squared. So here we take a root out of this equation number 7, and we get that according to equation number 7, x equals to plus minus to square root of 7,361. So here we have two solutions for x. The first solution is a positive square root of 7,361, and the second solution is negative square root of 7,361. But because of the fact that x is a length, x as a length, it must be a positive number. Therefore, we take into account only the positive answer. So here x equals to the positive square root of 7,361. That is actually equals to 8 plus 85 plus 85.796 units. I'll repeat again, x equals to 85.796 units. Okay, here the length of this line segment HC that is equal to x, it is equal to 85.796 units, a little bit greater than BF that is equal to 85 units. We finished with the first question. In the next step, I'll present to you the second question, and we'll solve the second question in two different methods. In the drawing, we have a semicircle. We know that AB, that is actually the diameter of the semicircle, equals to 6 units, and we also know that angle BAC equals to 30 degrees, and our mission is to find out the area of the green shape. Okay, so first of all, we will define the center of this semicircle as O. We know that the radius of any circle or a semicircle is half of the diameter. And we know that the diameter of this semicircle equals to 6 units. Therefore, the radius must be equal to half of it. That is to say, 6 over 2 is 3. So the radius AO equals to 3 units. The radius OB, it is also equals to 3 units. We join points O and C together by a straight line. Point O in the center of the semicircle, point C is the point of the semicircle itself. Therefore, OC is the radius of the semicircle, that is equal to 3 units. In triangle AOC, AO equals to OC. They are both equal to 3 units, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle, there are equal angles. So in front of those two equal sides, we have those two angles. according to the rule that I mentioned, those two angles must be equal to each other. So, but this angle equals to 30 degrees, therefore this angle must be also equal to 30 degrees. So, in the triangle AOC, this angle equals to 30 degrees, this angle also equals to 30 degrees, 30 degrees plus 30 degrees is 60 degrees, therefore the missing angle must be equal to 180 degrees. According to the rule that the sum of the angles in any triangle is equal to 180 degrees. So in order to complete the sum of the angles in this triangle to 180 degrees, this angle must be equal to 120 degrees. What is the area of a sector? If we have a sector, we have this sector, we have here a sector that could be any sector. So this is sector OAB that could be any sector. Note that AB is the radius of the circle that contains the sector, that is equal to R. OA is also the radius of the circle that contains sector AOB, that is also equal to R, and the angle between the legs of the sector is theta. Then the area of sector AOB, this is the way that you write the area. It means the area of sector AOB. This rounded sign is the sign for the area of a sector. So the area of this sector, sector AOB, will be equal to pi r squared, that is the area of the circle that contains the sector, times theta, that is the angle between the legs of the sector, over 360 degrees, that is the angle that the entire circle actually occupies. Again, the area of sector AOB equals to pi r squared times theta over 360 degrees. Here, the ratio theta over 360 degrees gives us the relative percentage that this sector occupies out of the entire angle, out of the entire circle. And when you multiply the relative percentage that this sector occupies out of the entire circle, when you multiply it by the area of the entire circle, that is pi r squared, we will get exactly the area of this sector. Okay? The relative percentage that this sector occupies out of the entire circle is theta over 360 degrees, and when you multiply it by the area of the entire circle, that is pi r squared, you will get exactly the area of this sector, sector AOB. We'll use this formula in order to find out the area of sector AOC. The area of this sector, sector AOC. So I'll copy sector AOC here, and we'll imply this formula in sector AOC in order to find out the area of sector AOC. We'll implement this formula in order to find out the area of sector AOC. So this is sector AOC. This is sector AOC that I copied from the original drawing. We'll use the new formula that I presented to you in order to find out the area of this sector, sector AOC. According to the new formula, the area of this sector, sector AOC, this is the sign of the area of sector AOC, the rounded sign here. So the area of this sector, sector AOC, will be equal to pi r square. R equals to 3, therefore pi r square is pi times 3 square times theta is the angle between the legs of the sector. The angle between the legs of the sector is 120 degrees over 360 degrees. 3 square is 9, so this expression in total equals to 9 pi. 120 degrees over 360 degrees is 1/3. So here, this will be 9 pi over 3. 9 over 3 is 3, so in total this expression equals to 3 pi. So in conclusion, we found out that the area of sector AOC equals to 3 pi square units. Okay, the area of sector AOC equals to 3 pi square units. In the next step, we'll calculate the area of triangle AOC. According to a new formula that I will present to you. Here, if we have a triangle ABC that could be any triangle, this is triangle ABC. This triangle, triangle ABC, the length of side AB equals to A units, the length of side AC is B units, and the angle between side AB and side AC is theta. Then the area of this triangle, triangle ABC that could be any triangle, the area of this triangle, triangle ABC, will be equal to A times B times sinus theta over 2. Again, the area of this triangle, triangle ABC that could be any triangle, is equal to A times B times sinus theta over 2. Now we will implement the new formula in order to find out the area of triangle AOC. So I copy triangle AOC here and we'll implement the new formula in triangle AOC in order to find out the area of triangle AOC. So this is triangle AOC. This is triangle AOC that is coming from the original drawing. The angle between AO and OC is 120 degrees. AO equals to 3 units, OC equals to 3 units. So this is triangle AOC that I copied from the original drawing according to the new formula. The area of this triangle, triangle AOC, will be equal to AO times OC times sinus 120 degrees over 2. Again, AO times OC times sinus 120 degrees over 2. So the area of triangle AOC will be equal to AO is 3, OC is 3, sinus 120 degrees is square root of 3 over 2, all divided by 2. Square root of 3 times 3 is 9, so it is in the numerator we have 9 times square root of 3 over 2 times 2 is 4. So in conclusion, we found out that the area of triangle AOC is equal to 9 times square root of 3 over 4 square units. We have already found out that the area of sector AOC equals to 3 pi square units. But what is actually the area of the green shape? From the drawing, it is very easy to see that the area of this green shape equals to the area of sector AOC the area of the green shape equals to the area of sector AOC minus the area of triangle AOC. I repeat again, the area of the green shape equals to the area of sector AOC minus the area of triangle AOC. So here we have already found out that the area of sector AOC equals to 3 pi square units minus the area of triangle AOC. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. So we actually found out that the area of the green shape equals to 3 pi minus 9 times square root of 3 over 4 square units. Or in terms of numbers, it is equal to 5.53 square units. I'll repeat again, the area of this green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. We finished with the first method. In the next step, I will present to you how to find out the area of this green shape according to the second method. We can actually calculate the area of this green shape according to a different formula. The area of this green shape it is actually equals to the area of the semicircle. It is equal to the area of the semicircle minus the area of triangle AOC minus the area of sector BOC. I repeat again, the area of this green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector BOC. I'll write it down. The area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of the sector COB. repeat again. The area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. What is the area of the semicircle? The area of any semicircle equals to the area of the circle over 2. The area of the circle is pi r square, and the area of the semicircle will be equal to pi r square over 2. Okay? It is pi r square over 2. Minus the area of triangle AOC, but we already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units minus the area of sector COB. Okay, so we know that the radius of this semicircle equals to 3 units, therefore r equals to 3, therefore r square is 3 square. So it is pi times 3 square over 2. It is the area of the semicircle minus the area of the triangle AOC, that is 9 times square root of 3 over 4 minus the area of sector COB. What is the area of sector COB? But before that, here we have 3 square is 9, so in total this expression will be equal to 9 pi over 2. 9 pi over 2. The area of the semicircle equals to 9 times pi over 2 minus the area of triangle AOC, that is equal to 9 times square root of 3 over 4 minus the area of sector COB. So we have to find out the area of sector COB. So I'll copy sector COB here, and we find out the area of sector COB or OCB but before that we have to find out the size of the angle between the legs of sector COB. We know that AB is the diameter of this semicircle, therefore it is absolutely a straight line. So if we focus on the upper side of the straight line AB at point O, here the sum of the angles must be equal to 180 degrees, according to rule number 3, that the sum of the angles on one side of a straight line is equal to 180 degrees. So this angle equals to 120 degrees. Plus the missing angle, in total they must be equal to 180 degrees. Therefore the missing angle must be equal to 60 degrees. In order to complete the sum of the angles on the upper side of AB at point O to 180 degrees, this angle must be equal to 60 degrees. So we found out that the angle between the legs of sector COB equals to 60 degrees. We have already found out that the area of any sector, is equal to pi r square times theta over 360 degrees. Here r is the radius that contains the sector, and theta is the angle between the legs of the sector. Okay, again the area of any sector is pi r square times theta over 360 degrees. We have already found out that the radius of the semicircle that contains the sector is r, that is equal to 3, so r equals to 3. Therefore, the area of sector COB will be equal to pi r squared. R is 3, so it is pi times 3 squared. And the angle between the legs of sector COB, theta equals to 60 degrees. So it is 60 degrees over 360 degrees. 3 squared is 9, so this expression in total equals to 9 pi. 60 degrees over 360 degrees is 1 over 6, that is 1/6. Okay, so it is 1 over 6. We divide both the numerator and the denominator by 3. 9 over 3 is 3, so in total in the numerator we left with 3 pi over 6 over 3 is 2. So in conclusion, we found out that the area of sector COB is equal to 3 pi over 2 square units. Okay, now we can find out the area of the green shape according to the formula that I presented to you. I'll repeat on the formula that I presented to you. We actually found out that the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of the sector COB. I'll repeat again. The area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. We have already found out that the area of the semicircle equals to 3 pi it is actually the area of the semicircle equals to 9 pi over 2 square units. Again, the area of the semicircle, we have already found out that the area of the semicircle equals to 9 pi over 2 square units. Minus the area of triangle AOC. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. Minus the area of sector COB. We have already found out that the area of sector COB equals to the area of sector COB equals to 3 pi over 2 square units. Okay, so here we have 9 pi over 2 minus 3 pi over 2 is 6 pi over 2 minus 9 times square root of 3 over 4. 6 over 2 is 3, so in total this expression equals to 3 pi minus 9 times square root of 3 over 4. So in conclusion, we found out that the area of the green shape equals to 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. We finished with the second question. In the next step, I'll summarize the lecture. We'll start with the first question, of course. In the drawing, we have rectangle ABCD. Inside rectangle ABCD, we have a circle. The tangent from point A to this circle equals to 33 units in its length. The tangent from point B to this circle equals to 85 units in its length. The tangent from point C to this circle is unknown. That is the tangent that we are looking for. So it is equal to x, and we have to find out the value of the tangent from point C that is equal to x according to what is given as the question. And finally, the tangent from point D to this circle is equal to 35 units in its length. Again, our mission is to find out the tangent from point C to this circle, that is actually the length of line segment C edge, or the length of tangent C edge, that is equal to x. Okay, so first of all, we defined the center of this circle as O. And here we have the radius OF is drawn to the point of tendency, therefore this angle equals to 90 degrees according to rule number 1. The radius OH is drawn to the point of tendency, therefore it is equal to 90 degrees. This angle equals to 90 degrees. The radius OT is drawn to the point of tendency, therefore this angle equals to 90 degrees according to rule number 1. And finally, the radius OE, it is drawn to the point of tendency, therefore this angle equals to 90 degrees according to rule number 1. We join points A and O together by a straight line. In this way, we created the green right triangle, triangle AEO. According to the Pythagoras theorem, AO square equals to OE square plus EA square. In the right green triangle, triangle AOE, AO square equals to OE square plus AE square. So AO square equals to OE square. O equals to 1, so therefore OE square is R square plus AE square. AE equals to 33, therefore AE square is 33 square. So according to equation number 1, we found out that AO square equals to R square plus 33 square. Then we joined points O and B together by a straight line. In this way, we created the yellow-green triangle, triangle OFB. In the yellow green triangle, triangle, and in the yellow right triangle, triangle OFB, according to the Pythagoras theorem, OB square equals to OF square plus FB square. Again, in the yellow right triangle, triangle BOF, according to the Pythagoras theorem, BO square equals to OF square plus BF square. So here BO square equals to OF. OF is R, therefore OF square is R square plus BF square. BF equals to 85, therefore BF square is 85 square. So in conclusion, we found out that according to equation number 2, BO square equals to R square plus 85 square. Then we joined points O and C together by a straight line. In this way, we created the orange right triangle, triangle OHC. In the orange right triangle, triangle OHC, OC square equals to OH square, OC square equals to OH square plus HC square. Repeat again, in the orange right triangle, triangle OHC, CO square equals to OH square plus HC square. So CO square equals to OH square. OH equals to R, therefore OH square is R square plus HC square. HC equals to X, here HC equals to X, therefore HC square is X square. So in conclusion, found out that according to equation number 3, CO square equals to R square plus X square. And finally, we joined points O and D together by a straight line. In this way, we created the pink right triangle, triangle TOD. In this right triangle, triangle TOD, OD square equals to TO square plus TD square. Repeat again. In the pink right triangle, triangle TDTO, DO square equals to TO square plus TD square. So DO square equals to TO square. TO is R, so TO square is R square. TD equals to 35, therefore TD square is 35 square. So according to equation number 4, we found out that DO square equals to R square plus 35 square. Then I copied the four formulas that we created according to the Pythagoras theorem here. And then I copied rectangle ABCD here, if it's circle inside it, and from the center of the circle, that is to say from point O, we go perpendicular on AB. So this angle equals to 90 degrees, this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AB is T. Actually, this perpendicular on AB must be also perpendicular to DC. Why? Because AB is parallel to DC. And because of the fact that AB is parallel to DC, so if here OT is parallel to AB, then the same perpendicular must be also perpendicular to DC, because AB is parallel to DC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to the rule that I mentioned and according to our construction. We define the touching point of the perpendicular from point O and DC as M. Then I draw from point O perpendicular on BC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and BC as point S. Here, because of the fact that side BC is parallel to side AD, then the perpendicular on BC must be perpendicular also on AD, or the perpendicular to BC must be also perpendicular to AD. Why? Because BC is parallel to AD. So here this angle equals to 90 degrees and this angle equals to 90 degrees according to the rule that I mentioned. And we define the touching point of the perpendicular from point O and AD as H. Okay, so here in quadrilateral AT edge O, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. Therefore, the fourth angle here must be also equal to 90 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. 270 degrees plus 90 degrees is 360 degrees. That is the sum of the angles in any quadrilateral. Likewise, in quadrilateral edge ODM, we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees. Likewise, in quadrilateral TBOS, we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees. And finally, In quadrilateral OSMC, we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees. So, inside rectangle ABCD, we have 4 quadrilaterals. All 4 quadrilaterals, all 4 small quadrilaterals have 4 right angles. Therefore, all 4 quadrilaterals must be rectangles. Okay? So we relate to those 4 quadrilaterals as rectangles. Why? Because they have 4 right angles. Then we define side AH as edge 1, we define side edge D as edge 2, we define side AT as B1, we define side TB as B2. We focused on rectangle AT, edge O. In this rectangle, the opposite sides are equal to each other. That is to say, AT equals to edge O. But we know that AT equals to B1 according to our construction, according to our definition. AT equals to B1. Therefore, edge O must be also equal to B1. Likewise, in rectangle AH-TO, AH must be equal to TO. But AH equals to edge 1 according to our definition. Therefore, TO must be also equal to edge 1. Likewise, in rectangle HO-DM, edge O must be equal to DM. But according to what we have already found out, that edge O equals to B1. Therefore, DM must be also equal to B1. Likewise, HD must be equal to OM in this rectangle edge O, DM. But we know that edge D equals to edge 2, therefore OM must be also equal to edge 2. Likewise, in this rectangle TOBS, side TB must be equal to side OS. But according to our definition, TB equals to B2, therefore OS must be also equal to B2. Likewise, side TO must be equal to side BS in rectangle TBOS. But we know that TO equals to edge 1, therefore BS must be also equal to edge 1. And finally, in rectangle OSMC, side OM must be equal to side SC. But we know that side OM equals to H2, therefore side SC must be also equal to H2. And finally, in rectangle OSMC, side OS must be equal to side MC. But we know that side OS equals to B2, therefore side MC must be also equal to B2. Then we joined points A and O together by a straight line. We focused on the green triangle, triangle ATO. The green triangle ATO, according to the Pythagoras theorem, AO square equals to B1 square plus H1 square. I repeat again, in the right green triangle, according to the Pythagoras theorem, AO square equals to B1 square plus H1 square. Then we join points O and B together by a straight line, and we focus on the yellow triangle. In the yellow right triangle, triangle OBT, according to the Pythagoras theorem, OB square equals to TB square plus TO square. I repeat again. In the yellow right triangle, triangle TOB, PO square equals to B2 square plus H1 square. Okay. And here we joined points O and C together by a straight line, and we focused on the orange right triangle, triangle OCS. In the orange right triangle OCS, OC square equals to OS square plus SC square. OC square equals to B2 square plus H2 square. Repeat again. In the orange right triangle, CO square equals to B2 square plus H2 square. And finally, we joined points O and D together by a straight line. In the pink triangle, triangle ODH, according to the Pythagoras theorem, DO square equals to B1 square plus H2 square. Again, in the pink triangle, triangle DOH, DO square equals to B1 square plus H2 square. Okay. So here So we created here another 4 equations for a whole square, b whole square, c whole square, and d whole square. So we have 2 different expressions for a whole square, 2 different expressions for b whole square, 2 different expressions for c whole square, and 2 different expressions for d whole square. Then we created equation number 1 that states that a whole square according to equation number 1 must be equal to a whole square according to equation number 2. Then we created equation number 2 that states that b whole square according to this equation number 1 must be equal to b whole square according to equation number 2. Then we created equation number 3 that states that c whole square according to this equation number 1 must be equal to c whole square according to this equation number 2. And finally, we created equation number 4 that states that d whole square according to this equation number 1 must be equal to d whole square according to this equation number 2. So those are the 4 equations that we created. Okay, and here we subtracted equation number 1 from equation number 2. Put it equation number 2 minus equation number 1. Equation number 2, here we have r square plus 85 square minus equation number 1, that is r square plus 33 square, and then we have the other side of equation number 2, that is b2 square plus h1 square minus equation number 1. In the other side we have b1 square plus h1 square. So this expression is, equation number 5 is the result of equation number 2 minus equation number 1. Then we open the brackets on this equation number 5, and we got here r square plus 85 square minus r square minus 33 square, that is equal to b square plus h square minus b1 square minus h1 square. R square minus r square is 0, so r square is get cancelled. h1 square minus h1 square is 0, so h1 square is also get cancelled. And we left only in equation number 5 with 85 square minus 33 square, that is equal to b2 square minus b1 square. Then we subtracted equation number 3 from equation number 4. Here in equation number 4 we have here r square plus 35 square minus equation number 3. Here we have r square plus x square. Then we subtracted the other side of equation number 4 from the other side of equation number 3 from equation number 4. In equation number 4 we have in the other side b1 square plus h2 square minus equation number 3 that we have here b2 square plus h2 square. Then we open the brackets on this equation number 6, and we got that r square plus 35 square minus r square minus x square equals to b1 square plus h2 square minus b2 square minus h2 square. So here r square minus r square is 0, so r square will get cancelled. In the other side of the equation we have h2 square minus h2 square, that is 0, so h2 square also will get cancelled. So from equation number 6, after we cancelled those two expressions, we left only with 35 square minus x square, that is equal to b1 square minus b2 square. Then we multiply the equation number 6 by minus 1. 35 square times minus 1 is minus 35 square. Minus x square times minus 1 is plus x square. b1 square minus 1 is minus b1 square. And minus b2 square times minus 1 is plus b2 square. So in conclusion, we found out that according to equation number 6, x square minus 35 square equals to b2 square minus b1 square. While according to equation number 5, we found out that 85 square minus 33 square equals to b2 square minus b1 square. Then you created equation number 7 that states that b2 square minus b1 square according to this equation, equation number 5 must be equal to b2 square minus b1 square according to this equation, equation number 6. So here I repeat again. Equation number 7 states that b2 square minus b1 square according to equation number 5 that is equal to 85 square minus 33 square must be equal to b2 square minus b1 square according to equation number 6 that is equal to x2 square minus 35 square. So according to equation number 7 we found out that 85 square minus 33 square equals to x square minus 35 square. Here we added 35 square to this equation, equation number 7, and found out that according to equation number 7, 85 square plus 35 square minus 33 square equals to x square. 85 square is 7,225, 35 square is 1,225, minus 33 square. 33 square minus 33 square is minus 1,089. That is equal to x square. 7,225 plus 1,225 is 8,450 minus 1,089. It is equal to x squared. 8,450 minus 1,089 is equal to 7,361. That is equal to x squared. So according to equation number 7, we found out that x squared equals to 7,361. We took out of this equation, equation number 7, and found out that x equals to plus minus square root of 7,361. So here we have two solutions that are possible for this equation, equation number 7. We have the positive solution and the negative solution. But because of the fact that x is a left, it must be a positive number. Therefore, only the positive solution is possible. That is to say, x equals to the positive square root of 7,361. That is to say, x equals to 85.69. X equals to 85.796 units. I repeat again. The area of this, the length of this line segment x equals to 85.796 units. So we finished with the first question. Then I presented to you the second question, and we solved the second question in two different methods. So in the drawing we have a semicircle. We know that AB, that is the diameter of the semicircle, equals to 6 units. Angle BAC equals to 30 degrees, and our mission is to find out the area of the green shade. Okay, we define the center of the semicircle as O. The radius of any circle is half the diameter. We know that the diameter of this semicircle is 6, therefore the radius must be half of it. That is to say, the radius must be equal to 6 over 2, that is 3. So AO, that is the radius, is 3 units. OB, that is also the radius of this semicircle, that is also 3 units. Point O is the center of the semicircle, point C is the point of the semicircle itself. This is exactly the definition of a radius. So OC is the radius of this semicircle, that is equal to 3 units. So in triangle AOC, CO equals to OA. They are both equal to 3 units, therefore they are equal to each other. We have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. But we know that this angle equals to 30 degrees, therefore this angle must be also equal to 30 degrees. So in triangle AOC, here this angle is equal to 30 degrees, this angle also equals to 30 degrees. 30 degrees plus 30 degrees is 60 degrees, therefore the missing angle must be equal to 120 degrees according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Then I presented to you the area of a sector. What is the area of this sector? Sector A or B, that could be any sector. We know that the legs of those two sectors are the radii of the circle that contains the sector. And the angle theta, this angle theta is the angle between the two legs of sector A or B. And the area of this sector, sector A or B, equals to pi r squared, that is the area of the entire circle, times theta over 360 degrees. Theta over 360 degrees gives us the ratio that is the percentage that this sector occupies out of the entire circle, and when we will multiply this percentage by the area of the entire circle, we get exactly the area of this sector, sector A or B. So theta over 360 degrees, that is the relative percentage that this sector occupies out of the entire circle times the area of the entire circle, that is pi r squared, gives us exactly the area of this sector, sector A or B. So pi r squared times theta over 360 degrees, it is the area of sector A or B. We use this formula in order to find out the area of this sector, sector A or C. So I copied sector A or C here, and we implemented the new formula in this sector A or C. Here we know that the radius of the circle or semicircle that contains the sector R equals to 3 units, and the angle between the legs of sector A or C is 120 degrees. So the area of sector A or C will be equal to pi r squared. R is 3, so pi r squared is pi 3 squared, times the angle between the legs of the sector is 120 degrees over 360 degrees. So here 3 squared is 9, so this expression in total equals to 9 pi. 120 degrees over 360 degrees is 1/3. So in total this expression equals to 9 pi over 3. 9 over 3 is 3, so in total this expression equals to 3 pi. So we found out that the area of sector A or C equals to 3 pi square units. Then I presented to you a new formula for the area of any triangle. Here we have triangle ABC. This triangle ABC could be any triangle. We know that the length of side AB is A units, the length of side AC is B units, and the angle between side AB and side AC is theta. Then, according to the new formula, the area of this triangle ABC equals to A times B times sinus theta over 2. Again, the area of this triangle ABC equals to A times B times sinus theta over 2. We implemented the new formula in order to find out the area of this triangle AOC. This is triangle AOC. I copy triangle AOC here. AO equals to 3, OC equals to 3. They are both the radii of the semicircle. The angle between the legs and the angle between side OC and side OA is 120 degrees. So according to the new formula, we get that the area of this triangle AOC will be equal to AO times OC times sinus 120 degrees over 2. AO is 3, CO is 3, so it is 3 times sinus 120 degrees over 2. Sinus 120 degrees equals to square root of 3 over 2, all divided by 2. So it is 3 times 3 is 9, so in the numerator we have 9 times square root of 3 over 2 times 2 is 4. So in conclusion, we found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. I repeat again, the area of triangle AOC equals to 9 times square root of 3 over 4 square units. Okay? Then we calculated the area, we have only found out that the area of sector AOC equals to 3 pi square units. We just right now found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. And what is actually the area of the green shape? The area of the green shape equals to the area of sector AOC minus the area of triangle AOC. Again, the area of sector AOC minus the area of triangle AOC equals exactly to the area of the green shape. I repeat again, the area of the green shape equals to the area of sector AOC minus the area of triangle AOC. We have already found out that the area of sector AOC equals to 3 pi. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4. So in conclusion, we found out that the area of the green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, so in terms of numbers, it is equal to 9.53 square units. We finished with the first method. Then I presented to you how to find out the area of this green shape according to the second method. According to the second method, the area of this green shape will be equal to the area of the semicircle minus the area of triangle AOC minus the area of sector BOC. This sector BOC. I repeat again, according to the second method, we found out the area of the green shape according to the formula that the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. The area of the semicircle is pi r square over 2. R equals to 3, so it is pi times 3 square over 2. 3 square is 9. So in total, this expression equals to 9 pi over 2. So we found out, in conclusion, that the area of the semicircle equals to 9 pi over 2. Okay. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4. And we just need to find out the area of sector COB. What is the area of sector COB? So I copied sector COB here. We know that OC equals to 3 units, OB equals to 3 units. They are both the radii of the semicircle, that is equal to 3 units. And what is the angle between the legs of sector COB? Here we know that AB is the diameter of the semicircle, therefore it is absolutely a straight line. And the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line AB at point O, here the sum of the angles must be equal to 180 degrees. So here, in the upper side of AB at point O, we have here 120 degrees. Therefore, the missing angle must be equal to 60 degrees in order to complete the sum of the angles on the upper side of AB at point O to 180 degrees. This angle must be equal to 60 degrees. So this angle equals to 60 degrees. And the area of any sector is pi r squared times theta over 360 degrees. R equals to 3, so pi r squared is pi times 3 squared. And the angle between the legs, that is to say, theta equals to 60 degrees. So it is 60 degrees over 360 degrees. So we found out that, in conclusion, that the area of sector COB equals to pi times 3 squared times 60 degrees over 360 degrees. 3 squared is 9, so in total this expression equals to 9 pi. 60 degrees over 360 degrees is 1 over 6. So in total this expression equals to 9 pi over 6. We divided both the numerator and the denominator by 3. 9 over 3 is 3, so in the numerator we have in total 3 pi, and 6 over 3 is 2. So in conclusion, we found out that the area of sector COB equals to 3 pi over 2 square units. And we know that the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. We have already found out that the area of the semicircle is 9 pi over 2 square units. The area of triangle AOC equals to 9 times square root of 3 over 4. square units, and finally the area of sector COB equals to 3 pi over 2 square units. 9 pi over 2 minus 3 pi over 2 is 6 pi over 2 minus 9 times 4 to 3 over 4 square units. 6 over 2 is 3, so in total this expression equals to 3 pi. So in conclusion, found out that the area of the green shape according to the second method equals to either 3 pi minus 9 times 4 to 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. Okay, I'll repeat again, the area of this green shape according to the second method equals to either 3 pi minus 9 times 4 to 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. Okay, thank you very much.